Okay, let's look at our inverse functions. Our inverse function, we produce them by interchanging, okay, our x and y values. So we swap them over and we come up with a new function called f inverse of x. That's the inverse, not f to the power of minus x. So the inverse function has a couple of properties. I guess the key ones really are, we know how to get it. The domain of the inverse function, well, because we're swapping our x and y, the domain of the inverse is the same as the range of the original. And similarly, the range of my inverse function is the same as the domain of the original. So they're two key important facts. To find the inverse function, well, we interchange the x and y values and then make y the subject. So rearrange it, so we'll get a function x equals, and rearrange that to make y equals. Really important here, only one-to-one functions have an inverse. We've spoken about one-to-one functions and many-to-one functions. Only a one-to-one function has an inverse. And the point of intersection between a function and its inverse is also, not only can we get f equal f inverse of x, but we could also let f or f inverse equal the line y equals x. So let's have a look at an example. Okay, first step really to find the inverse function is to interchange the x and y values. So, okay, read that. If y equals 2x plus 5, we swap the x and y values, so we can rewrite that as x is equal to 2y plus 5. Then we have to transpose the equation, so let's take 5 across to the left-hand side, so x minus 5 equals 2y. Divide both sides by 2, so we really end up with a half of x minus 5. Now the important thing is here we have to write f inverse of x, because remember y is not mentioned anywhere in our question. So the inverse function, okay, it looks like I might have forgotten to sketch the function, so we might try and come back and do that. So let's go to example 16. Again, we swap the x and y values. So that means x is equal to 2y plus 1, the square root of that. So let's undo everything. So let's square both sides. X squared equals 2y plus 1. Take the 1 across and then divide everything by 2. So we'll have x squared minus 1 is equal to, on 2 is equal to y. Again, y is nothing. F inverse of x. We lose marks if we don't write it as f inverse of x. F inverse of x is equal to half of x squared minus 1. We've got to state domain and range. So the domain of f inverse is equal to the range of the original. So our original graph is a square root function, and the range of that function is from 0 to infinity. The range of my inverse is the domain of that original function. So given 2x plus 1 has to be greater than 0, well, we can go negative a half to positive infinity would be the domain of f, and so there's my range of f inverse. B, exactly the same process. We want to swap the x and the y values, so we're going to rewrite our equation as x equals y squared plus 8y. Now in this case we need to get y in one place, so we'll complete the square here, and we do this every now and then. If I complete the square, halve the middle term and square it, we get plus 16 minus 16, so x is equal to y plus 4 all squared minus 16. So now y is in one place. Take 16 across, and then we'll take a square root. So we'll write that as y plus 4 is equal to, at the moment we're going to put plus or minus the square root of x plus 16. And we'll have to come back and have a look to remove the plus or the minus. So y is equal to negative 4 plus or minus root x plus 16. And we'll need to check the domain and range before we decide if it's a plus or a minus. So exactly the same, let's consider our graph of x squared plus 8x. The domain of g, I've written f there, but it's the domain of g is just x is greater than 0. It's written there for us, 0 to infinity. So that's the range of my inverse function. And the range of g is just a turning point situated on the axis, isn't it? So it's also from 0 to infinity. So that means the domain of my inverse is the range of my original, which is still 0 to infinity. Similarly, the range of my inverse function, so we should really be putting g inverse here, it's poor notation by me, is from 0 to infinity. Now, because the range of my graph is from 0 to infinity, that plus or a minus there, I can now decide, well, I'm not going to subtract anything because that will give me negative values, so it's going to be negative 4 plus the square root of x plus 16, and I'll remember to write g inverse there. Okay, if you have a look at this graph, we need to find the domain of the inverse function, which means we need the range of the original function h. So let's consider the original function, which is f plus g. So the domain of f plus g is going to be the intersection of the domain of f plus the domain of g. Both functions need to exist. So if we look at the domain of f is just the real numbers. And if we look at the domain of g, it's from 3 on 2 to 5 inclusive of the 3 on 2. So the intersection of those two sets is just 3 on 2 to 5, round bracket. So let's work out the rule. So now we need to work out the range of this function f plus g. So if I sketch x squared minus 4x plus x plus 3, we get x squared minus 3x plus 3. I want to do a quick sketch of that. So the easiest way for me, I thought, was perhaps to complete the square on it, halve the middle term, square it. So it's going to be plus 9 on 4 minus 9 on 4 plus 3, which is 12 on 4. So we get x minus 3 on 2 all squared plus 3 on 4. So that at least gives me a turning point. So now I can work out the range of that function a bit more easily. So if I do a quick sketch of that, I could see the turning point will be at positive 3 on 2, positive 3 on 4. There's my turning point. And it's a positive parabola, so it's just going to increase. Now the domain of that graph is just from 3 on 2, so it's just that right-hand part of the parabola. And we're going to stop at x equal to 5. So at x equal to 5, I need to substitute that into my function and try to work out what the function value is. So if I substitute that in, 5 is the same as 10 on 2. Minus 3 on 2 all squared plus 3 on 4. So I'm going to get 7 on 2 squared, which is 49 on 4. 49 on 4 plus 3 on 4 is 52 on 4, and 52 divided by 4 is 13. So 13 is going to be my upper value. Now, that means the range of my function, okay, the range of h is actually square bracket 3 on 4, because that's the turning point. Now 13, that should be a round bracket, shouldn't it? So that's a mistake there, boys and girls. So just note that. So the inverse function, the domain of h inverse is 3 on 4 to 13 round bracket, because the endpoint of 5 is not included.